In this lecture, let us discuss about statistical models in POS tagging. We have already seen what is meant by rule-based method, and we saw that they rely on predefined linguistic rules or predefined set of rules. Whereas the statistical models, they learn from large annotated corpora of text data. Okay, and also they use statistical techniques to determine the most probable tag for each word based on its context. So here it can be either the mathematical technique or probabilistic technique. So these models, they use them in order to find out the appropriate POS tag for words in a sentence. Statistical POS tagging model performance improves as it is trained on large datasets because it allows the model to generalize and handle ambiguous cases which cannot be handled by the rule based systems. And coming to the key concepts, first one is probabilistic framework. Statistical models rely on probabilities to predict the correct POS tag for each word, and these models use frequency and patterns observed in the training corpus to make predictions. Then training data. So statistical models, they learn from annotated corpus, which are collections of text where each word is labeled with its correct POS tag. And the size and quality of the corpus are very important for training the model. And the third one is conditional probability. Here model uses context of a word, that means either the previous words or surrounding words of that particular word, and then based on that the model computes the conditional probability of that word. Methods which comes under the statistical models are, first one is hidden Markov model. It is a generative probabilistic model that represents the underlying sequence of hidden states and observed events. So here hidden states are nothing but the POS tags and observed events are the words. Hidden Markov models are based on Markov assumption, which states that the current state depends only on the previous state, not on the entire history. So we need to remember this point. We have few components here. First one is state space, which are nothing but POS tags, set of all possible POS tags like noun, verb, adjective, preposition, etc. Then observations, there are words in the text. Then transition probabilities, the probability of moving from one tag to another tag. That is nothing but transition. Then emission probability, that means the probability of word being associated with a specific tag. Here the model computes the most probable sequence of tags given sequence of words, and this can be done using Viterbi algorithm, which is a dynamic programming algorithm for finding the most probable path in HMM. Second one is maximum entropy model. Maximum entropy always try to build the most unbiased model by using the available features without assuming more than the data allows. Here it assigns most likely tag to a word based on features, and also it ensures that no prior information is assumed. Here this entropy, it is a measure of uncertainty or disorder, and the idea is to make the model as uniform as possible given the constraints like relationship between words and their tags. Maximum entropy uses some set of features like a word itself or previous word, next word, suffixes and prefixes of the word, or contextual information. So by using all these things, most likely tag will be given to a word. Let us take the sentence, the dog runs. So first it will extract the features. So here, if you take the word runs, so as this word ends with yes, it is clear that it is a verb in the present tense. And the is a determiner as well as. So as this dog, it follows a determiner, it is considered as a noun. So based on this, model will predict respective POS tags for the words in the sentence. So the is identified as a determiner. Dog is a noun and runs as a verb in present tense. Maximum entropy models are more flexible than hidden Markov models because they do not assume simple independence between adjacent POS tags. So instead of that, they allow for complex feature interactions and are highly customizable. Then conditional random fields. So these are used for structured prediction, which are more powerful than hidden Markov models in some context. And also, unlike this hidden Markov models, conditional random fields model the conditional probability of a output tag given the input sequence directly without assuming a generative process. Conditional random fields do not assume independence between the tags and are able to capture long range dependencies and complex feature interactions also. They are trained using a technique called maximum likelihood estimation and use gradient based optimization. In POS tagging, conditional random fields model predicts a tag sequence by maximizing the conditional probability of the tag given the words in a sentence. And conditional random fields use features for individual words as well as the relationship between consecutive words. And here you can see the features, word level features and contextual features. Prefix, suffix, capitalization. So all of them comes under this word level features. Whereas previous word, next word and their POS tags falls under this contextual features. Let us see this example. Say the training data is she walks. So first, what are the features? We need to extract words separately. So she. So in the word she, S is a capital. So capitalized means it should be considered as a pronoun. Then walks. So this word ends with yes, which indicates that it's a third person singular verb. So based on this, model will predict the tags for the words. So here pronoun is assigned to this word she and verb third person singular is assigned to the word walks. Here the conditional random field will learn complex dependencies. Say for example the word she, it is followed by a word verb in the third person singular form. So here she is to be followed by verb, that too in a third person singular form. So this CRF will learn such type of complex dependencies, which makes it more powerful compared to either HMM or maximum entropy models.